Though we know who we are, yet we know not what we may be. So maybe I'm the one, or maybe I'm crazy. I'm from.
Welcome back to your No Malarkey Guide to Machine Learning. My name is Kalu. So in the last video, we installed the dependencies we needed and grabbed the data from kaggle.com. So why don't we go ahead and open our terminal. We downloaded the data train.csv and test.csv. And if yours is like mine, all of your data, all of your downloads should go in your downloads folder. So why don't we go ahead and copy that train.csv and let's put it inside of our desktop, inside of our multiple linear regression folder. So I did that for train.csv. I'm going to do the same thing for test.csv. So now both train.csv and test.csv should be in our multiple linear regression folders. Why don't we go ahead and cd into that multiple linear regression folder. And now that we're in this folder, we're going to go ahead and activate the virtual environment that we made last time. You can see that we're activated, and now we're going to go into Python, do our imports. Import numpy as np, import pandas as pd, import matplotlib.pyplot is plt, import seaborn is sns, and that is all for now. So now that we have our imports, why don't we get our data, and data equals pd.readcsv, train.csv, and now we have our data. We can do data.head to look at just the first 4 rows of our data. Why don't we do data.columns to look at our data, to look at our data columns. So these are all the columns in our data. So it is a large data set that has a lot of potential predictors we can use, or potential independent variables that we can use to predict our target variable of sales price. So why don't we go ahead and get sales price equals data sale, and I know to write it like this. Don't forget it's case sensitive, so it's capital S. We have to use capital S and capital P as well too. And I know to write it like this because it says so right here. So now we have price. So why don't we look at price? So if you want to understand more about these columns right here, maybe you want to understand, for instance, what does it mean here when we say BSMTQUAL? Or what does it mean here when we say, let me look for one that, there's one in particular that I'm looking for. I can't even find it. But if you want to know what these mean exactly, then you just want to go to Kaggle, go to the data set on the Kaggle right here. So this URL, and then we just click on data. And then from data, we want to click on data description.txt and go ahead and hit download. And it'll take you to a description of all of the text. And here we can see what all of these things mean. What I was looking for was this right here, GLV area. This is the above grade or above ground living area square feet. That is what we're going to use to try to predict the square feet. So we're first only going to look at this with 2 independent variables to predict our square feet. We're going to look at the greater living area square feet, and why don't we also look at the garage area square feet. So let's get these garage area equals data garage area, and I know to write it like this because it says so right here. And then let's get area, just greater living area is this ground living area is GRLIVAREA, and there we got it. Why don't we call it, instead of garage area, why don't we call it G area, just to make it a little bit easier. And we can also call it X1. Let's do X1 equals area, and X2 equals G area for garage area. And actually, I like using this right here. I think this looks better. All right, so now we have our dependent variables, and our predictor variable now we have our independent variables x1 and x2, and our dependent variable is, if you forgot, price, sales price, which we already have in a variable. Now we can look at some of the data about this. So why don't we do area.describe, and remember we could do area or x1, that both points to the same thing. So area.describe, and don't forget to call it like this. And then we can see that the average area is 1,512 square feet, with a standard deviation of 525. And you can see all this, and there's 1,460 points in this data set. So we have data for 1,460 homes. That's quite incredible. So why don't we look at garage area .describe, don't forget to call it. And the average garage area is 472 with a deviation of 210. And again, we have 1,460 in our data set. And we call it price.describe. And here we have 1,460 in our data set, total amount of data in our data set, total amount of observations in our data. So we also have an average of $180,921 and a standard deviation of $79,000. So this is pretty good. This is not bad. So we have now just looked at a little bit of our data, gotten a bit of a feel of what the average count is, or what the total count is of observations we have, what the average is for the predictions, for the predictor variables that we want to use, and what the average is for the target variable that we want to go after. So in the next tutorial, in the next video, we're going to talk about this linear equation formula, the formula for linear equation. But first, we have to talk about some assumptions that we use, that we need to hold true in order to even use this linear regression formula. And that assumption is that we have a normal distribution. We're going to talk about what that means in the next video. See you guys at the next video. I know this has not been that much programming, but we were able to do just quite a lot of just the description. See you guys at the next video. Peace.
Financial freedom, my only hope.